So our rivers won't just continue to erode downwards forever. They'll erode to what we call base level, and that's the lowest point a river can erode. Usually this is defined by the potential energy. So what happens is once the river reaches the potential energy, or excuse me, the base level, the potential energy goes to zero, so it's no longer going to erode. Of course, the ultimate base level is sea level. That's where water is most comfortable. And streams in general can't erode below sea level, so you'll never find a river or a stream that's below sea level. However, we can see that lakes can easily act as a temporary base level. So let's take a look at a different way that our water can erode. Sometimes we can form these things, valleys and canyons. So valleys are where we have these very gently sloped sidewalls, making a V-shaped valley here. We've got this nice wide bottom and these nice sloped sides. Or we can get a canyon, which tends to be much steeper sides where you see lots of cliffs. And usually the way these form is through undercutting. However, over time, as you can see here, right, as that material is undercut, it can easily start to break apart and break away and form a nice big valley. So we can also, as we mentioned before, some of these areas where we can get water flowing is an area called a rapid. And as you can see here, this is definitely where we've got low discharge, right? We're moving very small particles. But you can see at higher periods of discharge, the water would flow over those boulders, creating very turbulent flow, which is what people that do whitewater rafting generally enjoy doing, right? Going over that turbulent flow. Waterfalls have the highest amount of kinetic energy. So what's basically happening in a waterfall is water is in free fall, but gravity is solely acting upon the water to pull it downwards. So you can see that there's a lot of erosion that happens here at the base. And of course you get undercutting, right? All that stuff we talked about before. So Niagara Falls is an interesting case. So basically what we have is Niagara Falls to the north and Ontario to the south, and there's a 55-meter drop between those two lakes. As a result, we get this nice big waterfall, and that's Niagara Falls. And Niagara Falls is slowly eroding upriver, as we saw, right? Because as that water falls over, it's eroding, it's undercutting the bottom here, so it's slowly working its way backwards. What's interesting, in 1969, there's a temporary diversion of the fall where they literally turned off the waterfall. So you can see how much material collects here, right, at the base. So you got all that water flowing over the edge, and then we can basically turn it off, and you can see all of that pretty amazing material. So it shows you how fast it's actually eroding. Alluvial fan, which remember is what we saw in our sedimentary rocks. Alluvial fan is basically a delta that forms at the base of the mountain. So as my water works its way down the mountain, it's moving downwards really fast. It hits the bottom part of the mountain, and the velocity of the water changes, and it goes very slow. As a result, we have very low competency, and all that material drops, right? And that's what we call the alluvial fan. We can also get braided stream environments. This is where we don't just have one river channel, we have several river channels, and they're constantly moving across each other kind of in a braided fashion. So they're actually pretty complex systems.